Hello, thank you all for joining our talk on how to properly benchmark Redis. My name is Shwartz and I'm a product manager at Redis Labs, and with me is Filipe Oliveira, who is our performance engineer here at Redis Labs. In this talk, we want to give you the tools and the knowledge as a Redis user and as a Redis developer to properly benchmark Redis yourself. Now, no special background in performance benchmarking is required. In the talk, we are going to cover some basic ideas around benchmarking and how to avoid some common pitfalls. We will go over the existing and recommended tools for conducting Redis performance benchmarks, and eventually Filipe will demonstrate how to use those tools and how to make sense of the results. But first, let's start with the why. Why should we care about Redis performance benchmark? So why should we care from the user perspective? There are three things you probably want to care about. I think the most obvious ones is that if you want to test the performance of your application, then you need to know also how to benchmark Redis in order to make sure Redis will reach the needed performance. Second, you want to ideally size your infrastructure according to your needs. Now, maybe you are using extra resources and you are paying for them, and maybe your infrastructure is actually your bottleneck. So we need to verify that. And of course, you probably need to make sure Redis is the right technology for you, so you will need to be able to truly compare Redis to other technologies. Now, as a Redis developer, again, there are two things you should care about. You should make sure that the new features you introduce to Redis don't degrade Redis performance. But regardless of that, you should also understand the new features performance. Now, of course, that if you want to improve Redis performance, you will need to run extensive benchmarking. So now that we know why should we care, let's briefly go over some general concepts around performance benchmarking. Now, it is easy to forget that performance benchmarks are eventually a type of test. And like any other testing scenario, you need to verify several things in order to conduct a valid test. So let's go over the list of things that you need to verify. First, you should use a stable testing environment and minimize the environment variance. You need to make sure that your testing environment matches your production environment, because what we don't want is to deploy in production and later find out that our infrastructure can handle the predicted loads. So this is regarding the environment. Now, second, you should define clear KPIs. Don't forget that you are testing your own application, not some imaginary scenario. Now, don't get me wrong, imaginary scenarios are fun, and it is important to know what is the maximum reads per second for your database. But eventually, you don't care how Redis performs under imaginary workloads. You should care about your application performance and how Redis fits your own use case. Third, make sure you use battle-tested tools. Please don't use your own tools. I think it's pretty obvious. And like any other testing scenarios, you need to make sure that the test is not flaky, meaning you need to make sure that the results are reproducible and somewhat deterministic, so you can go over them over and over again. Now, for Redis developers, make sure you reduce the probing overhead and minimize the changes you are testing, because it will be easier for you to isolate the problem. Okay, now a very important concept is please understand what you are testing and what you are measuring. This is crucial. Now, what do I mean by that? First, profile your application. Make sure you understand the commands, data size, and data types that you are using, and also the ratios between reads and writes commands. For example, if your application is writing 10% of the time and reading 90% of the time, then you don't have use in a benchmark that checks for 50-50 reads and writes, because it doesn't mimic your application. So you will never understand what your application is capable of. So please profile your application first. Second, understand what you are measuring. If you are measuring the maximum operation per second, for example, then you should not care so much about latency. You should test different piping sizes and use maybe other techniques in order to increase the ops per second, even if it hurts your latency. because you test ops per second. And if you are measuring latency differences, for example, between environments, then you should keep the number of operations per second stable. This will allow you to understand the latency of different environments. So you need to change the tests according to what you want to measure. Third, understand your setup. For example, one of the common mistakes we see when people benchmark clustered Redis is that they don't really use the cluster abilities. So if you are using clustered Redis, then you should make sure that your benchmark hits all the nodes in the cluster, meaning that you spread your read and writes on enough hash slots. Otherwise, you will not reach the true potential of the cluster, and you will not conduct a proper test. So please, profile your application, understand what you are measuring, and understand your setup. So regarding stable environment, eventually it boils down to two things. First, truly understand your underlying infrastructure. I think you need to ask yourself what you are using. This is the basic idea. Second, use production grade infrastructure. If you are using on-prem servers, then use those. If you are using cloud, then use the cloud provider and the VMs that you will use in your application, in your production, sorry. Regarding key performance indicators, as we said, profile and understand your application. Use battle tested tools. We will go over the recommended tools for Redis in the next slides. And make sure your results are deterministic. The results do tend to change a little, so you can use, for example, K-based testing methodologies or other methodologies that can represent a set of tests in order to reduce the flakiness. So I want to go over some common pitfalls. We chose the two that are most common that we saw around all the benchmarks that we tested. So the first one, we call it the client bottleneck. Now it is very important to verify that once we reach a certain limit, and we will reach it, that it is actually the limit of the database and not some client bottleneck that we didn't participate. For example, we can see here two CPU utilization graphs, and we can clearly see that the DB is far from reaching the limit. There are 20% extra CPU resources. So when you are checking the results, make sure you really reach the database limit and not jumping to conclusion because you reach the client limit. Now the second common pitfall that we saw a lot, and it's going to have the same conclusion. It's the infrastructure bottlenecks. And the most common one was the network bottleneck, even though there are other things to look out for. In this example, we benchmark Redis and we reach the maximum bandwidth, and all of a sudden our rate drop. It looks like we reach some bottleneck, obviously. Now maybe it's the limit, it's the database bottleneck. So we check the CPU utilization, and we can see clearly that the DB is not working that hard. So it's not the database limit or the bottleneck. So it must be something else, and in this case it really was. So we prove that it was the network limit. We use the iPerf, and we can see that we actually reaching the network limit. So again, the same conclusion. We should understand first what is causing this effect before continuing the benchmark and reaching to conclusion. Now there are other common pitfalls here in this link. I think one of the most important concepts in performance benchmarks is to be able to explain your results. Ask why is the number of ops per second is X and not Y, and all those things before jumping to conclusion. This is the most important conclusion you can take from this part of the lecture. With this conclusion, I will hand over the screen to Filipe, who will go over the different tools of Redis benchmark and will present how to use them to benchmark a demo application.
Okay, so now let's talk about two of the most common benchmarking tools for Redis. Redis Benchmark and Memtier Benchmark. We'll start by Redis Benchmark. Redis benchmark is part of the core Redis repo and developed and maintained by the community. Let's focus on its pros and cons. With regards to the pros, it's a very easy way to get some ballpark numbers. It's built in on the Redis repo, so if you have Redis server, it's very likely that you have also Redis benchmark available there, and it's an easy way of getting or simulating simple command patterns. With regards to the cons, by default it will not print the errors. So, for example, if you commit a typo on a command, or you set a wrong command argument, you will be misled by the showcased ops per second, for example. It tracks multiple commands capabilities on the same benchmark. So, for example, if you want to benchmark writes and reads at the same time, which is a very common pattern, you are not able to do it with Redis benchmark. But hold on a little bit, we'll talk about it afterwards on memtier. And by default, it will also benchmark just a single key on with these default configurations, which means that, for example, when you want to benchmark Redis cluster or more complex scenarios, or you want to benchmark more complex key space range, you should take that into account. And as you saw before on Or's part of the presentation, it's very easy to reach client bottlenecks, so you should take that into account. It's very likely that Redis benchmark will hit one core limitation or one thread CPU usage limitation before Redis server himself. And now to our most advanced benchmark tool for Redis, memtier benchmark. It's developed in-house on Redis Labs, and it has been open sourced, and you can check it on the following GitHub repo. And it's been majorly adopted by the community, and it's maintained not only by Redis Labs employees but also by community members. With regards to the pros, as I said before, it supports multiple command benchmarks. So, for example, if you want to benchmark writes, reads, deletes at the same time with different command ratios, you will easily be able to do so. It has different data access pattern simulations. So, for example, you can simulate auth and code portions of your data. It's very advanced with regards to metric correction and metric exporting. And one of the examples of a metric that's exported and that's provided in full detail is the latency. So you are able to do, for example, a full latency analysis based on the full latency spectrum with the data exported from memtier benchmark. We'll talk about that on the demo. With regards to the cons, or with something that we aim in the future, right now memtier is targeted for benchmarking your database or benchmarking your system up to the stress point. So basically, it tries to reach always the stress level of your database. If you want to benchmark something more related to latency constraints or to throughput constraints, for example, I don't want to benchmark or to understand what's the maximum throughput of my database, but I want to understand what's the latency at a rate of 1,000 commands per second. Right now we are missing that feature, and it's something that we've been discussing, and we are aiming to provide in the future releases on memtier benchmark. So if you have an opinion, or if you have ideas about how to properly implement it, please follow the following GitHub issue, share your thoughts. We are more than welcome to accept both issues and PRs to that tool. Now that we have revised two of the most used benchmarking tools for Redis, we are going to use one, memtier benchmark, to simulate a real-life scenario. So let's imagine that you, on your company, you are going to develop a new application, and you want to understand if Redis will be a good fit for the underlying database to be used. Product has come with a set of requirements and questions that they want us to answer. So let's go through them. So they want us to be able to answer what's the maximum achievable throughput that they can expect from Redis, given the specific dataset constraints and data access patterns. The infrastructure team has provided us with a very specific machine type to be used, a very specific OS, and they also want us to start as simple as possible. So they want us to use a standalone Redis. After discussing this new application with the product team, the engineering team has decided that Ashes are the best suited data structures to be used. They expect at max to on database to be present only 1 million of keys. They expect the average key size to be 1 kilobyte. And one very interesting thing is that product already knows what's the expected access pattern to their application. So they know that it will be very read heavy. So 95% of the requests will be reads and 5% of the requests will be writes. So we want to simulate that type of access pattern on our benchmark. Apart from understanding what's the maximum achievable throughput on the application, product also wants to be able to say if we are going to be able or not to cope with the service level agreement that we have, the 99% of the requests at maximum throughput to be served below 10 milliseconds. Apart from that, we also know that at max, we'll have 50 concurrent connections to the database. So we also want to simulate that on our benchmark. So let's get to it. And to be able to answer those questions and to be able to cope with those requirements, we'll set up infrastructure with a minimum set of machines. So 3 machines. We're going to have a benchmark client, we're going to have a machine specifically for Redis server, and we are going to have a machine just for telemetry collection so that we really understand what's going on and we are able to explain the results that we are getting. In the best interest of time, we are providing you with the repo with all steps to be able to replicate this on your site. So please go ahead, go to that repo, follow it, and check if you can achieve the same results that I'm going to share with you guys. Prior than doing the benchmark himself and the analysis of the results afterwards, you need the infrastructure and the tooling to be properly set up. To help you out on that, if you check our GitHub repo, you'll see that there's a folder called infra. Within infra, you have all scripts to be able to deploy and configure the machines properly. At the end, you should be able to get a similar output of the one that I'm retrieving now, which contains the client and database internal and external IP addresses to be able to connect and do the benchmark, and also the Grafana server external IP address to be able to properly do the analysis afterwards. On that same repo, you will find a PDF file named AutoReport guide that basically contains everything that you should expect of a concluded benchmark task, from the requirement setting up to the test description, how to do extra tests to the underlying network conditions, how to do the prepopulation, how to do the benchmark himself, and a set of guides on what metrics to look at after the benchmark is done, and how to also properly do a deeper analysis on the latency after the benchmark ended. So please use it. It contains much more detail than what we can provide here on this 20-minute presentation. So please use it in your favor and share your thoughts about it. We will be more than glad to talk with you guys afterwards about on how to do reports, on how to do benchmark analysis afterwards. Okay, now jumping into the part of doing the benchmark himself. So prior than collecting the benchmark numbers, we need the prepopulation stage, also done with memtier using the client machine. So let's jump to it. To do the prepopulation, we'll just focus on the memtier machine on the left side corner, and I'll just pass the memtier command arguments. I really want us to focus on these 3 set of arguments. The first one basically specifying the data size. So basically, is this that controls how large will the keys be. Then we have the key maximum configuration, but that basically allows us to control the range of the key space. So basically how large we want it to be and how large we want our benchmark to be in terms of both number of keys and consequently the size that they will take in memory. And then we have the argument that is basically providing us with a way of specifying which command we are going to benchmark, and it contains 2 very specific placeholders. We have, if you guys focus on it, we have hset, key placeholder, field, data placeholder. The key placeholder will be replaced by the key number, and the key number will be something between the key minimum and maximum that we specified. By default, the minimum is 0. The maximum, as we said before, is 1 million. Then we have the field. And then we have the data placeholder. This data placeholder will be replaced by random generated data with the size that we specified on the data size command argument. If we run this command, we should see immediately the number of keys going up and the number of hops per second also following up as well. Now we just need to wait a little bit for it to be over. As soon as we hit 1 million keys, we are ready to do the benchmark. Let's just wait a couple more seconds and we are done. Now on to the stage that we prepared everything for. So basically we deployed the machines, we pre-populated the data just to reach here and to have a meaningful data set, to have a stable environment, and now to run the benchmark. So let me pass the benchmark command that we are going to use and explain it to you guys. If you compare this command that we are using right now with the command with the pre-population, they are both similar, so they share command arguments. As you can see, we have the key maximum and we have not one command specification but two command specifications, and this is what I really want us to focus upon. So let's go over to through the arguments that were not present on the pre-population stage. So basically now we are not interested in just sending 1 million keys to the database for the pre-population. We really want the benchmark to be run for a long time in a meaningful manner and multiple times. So basically what we do is we specify the test time to be 5 minutes, 300 seconds, and we specify that we want 3 runs to be made. So basically we want to try to avoid as much as possible our results being influenced by some spurious issue on the machine, by some noisy neighbor. So it's a really best practice to run your benchmark multiple times, run it for a long time, and always assess after the benchmark or even during the benchmark the machine metrics to make sure that it all makes sense. So bottom line, we now specify test time and run count for having it run for large time and multiple times. The key maximum stays the same. We have now added a new argument called distinct client seed. What this makes is that we are going to, given that we want to simulate 50 clients, and we don't want them to eat the same keys always, right? But we want the randomness to be deterministic. So we want randomness. We don't want clients to be eating always the same keys of each other. So we start with different deterministic random seeds for each client. So basically, if you run your benchmark 1, 2, 3 times, the outcome will always be the same, but the clients will be eating different keys during the benchmark. And different sequence of keys during the benchmark. Then we have not only one, but we have 2 commands specification like we wanted on the benchmark. So basically we now have the age set that we had before. And the interesting part is that given that we wanted to simulate different key ratios, we add the command specification and we also add the command ratio specification. So these two go along together. So basically you specify the command and command key ratio in pairs. So we specify the age set, command ratio of 5, and then we specify the age get all, also using the key placeholder that we've discussed before, and a command ratio of 95. Altogether, this will make sure that 5% of the entire commands that we issue to the database will be writes and 95% will be reads. Apart from the arguments that we've discussed up until now, we also have arguments that are purposely set to store the results. So we are storing 2 types of results here. We are specifying store me the high dynamic range of latencies in a standard format that you guys can check on MemTier. We have it fully detailed there. So basically we are saving as much information as possible about the latency so that you can basically afterwards do a full analysis and not an analysis based only on a number. And we also want to export the entire result to a JSON file. So we will have the full latency spectrum saved to a specific file in a specific format, a standard format, and you will have the JSON file containing the benchmark overall results. And that's it. We will start this benchmark. It will run for 15 minutes, so we'll do a quick break, and I'll get back to this session as soon as the benchmark ends. Let's start it, see it all goes okay, and I'll pause the session and come back in 15 minutes. Now that the 3 runs have fully completed, we are presented by MemTier with a summary report containing the best case results, worst case results, and aggregated average across the number of runs that we set memtier to do. We're not only interested on a specific run, a best case scenario, worst case scenario. We want to understand what's the variance between the best result and the worst result, so that we are aware of the variance that exists within our testing environment. As you can see, the maximum throughput of the best run result was 157 k ops per second on overall, and the best and the worst case result was 149 k ops per second. Not only we should look at the achievable throughput, but also on the average latency and the full latency spectrum to understand how stable and how different is the percentile 50 versus the percentile 99 of both best case scenarios and worst case scenarios. And as you can see, the difference is very, very small. That showcases that we are running in a stable environment as expected. We place the machines in an optimal networking scenario, and we run this test multiple times without interference of anything else on the benchmark runs. So this is expected, but it's extremely important to always make ourselves this type of questions. So don't look just at the best run result, look at the best, worst, and all information that you have to understand how stable your system is. If you remind ourselves, we wanted to understand what's the maximum achievable throughput, but we also wanted to be able to answer product if the service level agreement that we set ourselves to, basically 99% of the requests being served below 10 milliseconds, was something feasible with Redis, with the type of data structures that we are using. And yes, if you see, by just looking at the summary report, either the worst best case result or the aggregated average results present a percentile 99 below 1 millisecond. We are at 0.5 milliseconds a percentile 99, meaning that 99% of the requests were served below 0.5 milliseconds, including the network hop, including basically round trip time. But we can do better than this. We can do better than just providing this table to the product management. We can do a full latency analysis based upon the exported data that memtier provides us. So taking the exported latency files in the HDR format, we can take those latency files and plot them using a standard plotting tool available on the internet. And you have latency by percentile distribution broken by the benchmark commands that we did. And bottom line, as you can see, even 99.99% of the requests are served below 1 millisecond. And if we keep doing the analysis further, we will see that the 5 nines, so 99.999 is served below 10 milliseconds. So you can be completely confident about the promises that we are making around the service level agreement based upon the performance of Redis. Now that we are past the demo, we wanted to close this session with some key takeaways. So with regards to the clients, what we really want you guys to focus is on always using battle-tested tools that are deterministic, that are performant, that are not the bottleneck or the first bottleneck when compared to the application you are measuring. Always use stable environments, meaning that if you detect some change on a new benchmark run that you did versus a benchmark run on the past, you want to be sure to be able to pinpoint the changes to your application, and you don't want the changes to be influenced by instabilities on your environment. With that said, it's strictly and extremely important to always know the limitations of the infrastructure that you are using, meaning that measure the limits of the network, measure the performance of the CPU, the memory, of everything that can deeply impact your application. You should be able to know what are the hard limits that you should expect based upon the machines that you are using. In third, always use key performance indicators. Meaning that don't rush to run benchmarks just because you need numbers. Set yourself and discuss the performance indicators or the indicators that matter to your product, to your business, and focus yourself on being able to produce benchmarks that truly pinpoint the performance of those critical indicators that the business has provided you. Know your application. By this point, we mean understand exactly what can influence your application performance. So every moving part that sits below your application, you should be able to correlate the performance of that moving part with the performance of your application. And in fifth and last, but I think that we think that it's very, very important, is to be critical and always share your thoughts with the community. So always ask yourself if the results that you are seeing are valid, if the results that you are seeing make sense and you are able to prove them with numbers. Bottom line, everything should be able to be double checked and proved with metrics. This is the only way of making sure that the results you are showcasing are valid. And with regards to more resources, given that this session is just 20 minutes and we want it to be as broad as possible and touch on several points that we think that are very important when doing benchmarks, and if knowing that we need much more detail, please follow along on these two links resources, one on Redis Labs and another one on the core Redis website. Read them, share your thoughts about them, suggest changes, really be open about the benchmarks you want to see and the benchmark results that we are getting. Be critical. We are really hoping to receive your feedback about benchmarking of what you guys think it's important to showcase with regards to the performance of Redis, or with regards to how the performance of Redis will impact your application. And that's it. With these closing remarks, we ended our presentation. We hope you guys enjoyed watching it as much as we enjoyed recording it. And hopefully next year this event will be in person. Let's get in touch. See you guys later. Bye bye.